All right, we're going on to chapter 17, change of phase. I'm going to dismiss my image so it doesn't interfere with the presentation. Um, so in this chapter, we're going to discuss phases of matter, evaporation, condensation, boiling, melting, and freezing, energy, and changes of phase. And we'll discuss a few other topics, but these are the main points. Matter exists in four common phases. Changes of phase require transfer of internal energy. Uh, we have the solid phase. You can think of ice, liquid phase, ice melts to water, gaseous phase, water vaporizes to vapor, and the plasma phase. Vapor disintegrates to ions and electrons. We don't deal with plasma much. We won't really discuss it in this chapter, but plasma is what you get in a fluorescent bulb. The gas becomes ionized and it glows. So, but we're not going to talk about plasma in this chapter. Oops. Let's see. Um, the phase of a material depends upon the temperature and the pressure. Um, Changes typically are from a solid to a liquid to gas and plasma. They require that energy be added to the material. Added energy causes the molecules to move more rapidly. We'll see, we'll towards the end of the chapter, we'll see how much energy it takes to change 1 gram of water uh, from a very cold ice to steam, and you can calculate that. You're not going to be required to calculate it, but you can. Okay, evaporation is the change of phase from liquid to gas. So they're showing here liquid water, water molecules, H2O. You see the two hydrogens on the oxygen. So evaporation is the energetic molecules get to the surface. It's possible for them to break away, but it's also possible for the water vapor, the little vapor molecules to come back into the surface of the water and condense. So if everything's in equilibrium, you won't see any loss of water because as many molecules that are leaving the water are you have molecules returning and it stays in equilibrium. Now, if it's a little warmer, if it's a warmer day, you're going to release more molecules to evaporation. Okay, molecules in liquid move randomly at various speeds, continually colliding into one another. That's one of the, I forget if it's a homework or a quiz question. There's a variety of speeds, high speeds, low speeds. So there are various speeds. Some molecules gain kinetic energy while others lose kinetic energy during collision. You have a fast molecule crashing into a slow molecule. The slow molecule will gain the kinetic energy and the fast one will lose it. Some molecules gain kinetic energy while others lose kinetic energy during collision. Some energetic molecules escape from the liquid and become gas. The average kinetic energy of the remaining molecules in the liquid decreases, resulting in cooler water. So evaporation results in cooling. When wet, the cloth covering the sides of the canteen promotes cooling. When it's wet, it evaporates and that results in cooling, and so it cools the water inside the canteen. Okay, evaporation is important in cooling our bodies, preventing us from overheating. Sweat glands produce perspiration. The water on our body absorbs body heat as evaporation cools the body, and it helps maintain a stable body temperature. Now, some animals don't sweat. Dogs, they don't have sweat glands, so they pant, and the panting evaporates some of the moisture in the mouth and trachea, and that helps cool the dog. They show some pigs here that they cool by laying in the water. Okay, sublimation. Sublimation is a form of phase change directly from solid to gas. Example is dry ice. There's no such thing as liquid carbon dioxide. Um, Dry ice, which is frozen carbon dioxide, goes directly from a solid to a gas. Mothballs uh, sublimate, and so I know that sometimes in our uh, ice bucket in the freezer, uh, they it almost looks like the ice cubes have melted and joined together, but that's probably just from sublimation. Uh, okay, the toy drinking bird operates by the evaporation of a solvent inside its body and the evaporation of water on the um, outside surface of its head. Um, so we'll look at it in steps. The bird has like a felt covered head. There's felt on the head, and in order to get this started, you dip the head of the bird in water, kind of soak it, and it'll start this cycle. Let's look at the cycle. The evaporation of water from the outside of its head lowers its temperature inside as well, causing the condensation of some of the solvent vapor. Um, Inside the head, reducing the vapor pressure there. So as this evaporates, this cools, that lowers the pressure in this part of the head. It's a glass bulb, and it lowers the water pressure. That means there's the water pressure is higher here, and it pushes the fluid up. As the fluid pushes up, it makes the top heavy, and it leans forward. The relatively greater vapor pressure in the lower body forces liquid upward. So as it goes upward, it becomes top heavy and it tilts. When the liquid is high enough, the bird pivots forward until the bottom of the tube no longer is submerged in the liquid, allowing the liquid in the tube to drain to the lower body. You can see that it's slow draining down. This this wets the felt surface on the beak and head, because it's felt, causing the cycle to repeat. And I won't do D, because if you look at the A and D are exactly alike. So it just starts the cycle over again. Okay, and that is the end of part one on our change of phase.